sine squared of theta plus the cosine squared of theta equals 1. This is true, but how do we know that this is true? Where does this even come from? Now, if you look at this for a little while, you might be thinking, wait a minute, this looks awfully similar to the Pythagorean theorem. So let's try using the Pythagorean theorem to figure out where this comes from. Now, we know for the Pythagorean theorem, we need a right triangle. So let's just first start out by drawing a right triangle. So right here, we have a right triangle, just like that. So that's a right triangle. I'm going to call the horizontal leg x, and I'm going to call the vertical leg y, and I'm going to call the length of the hypotenuse r. So to use the Pythagorean theorem with this right triangle, we would just write x squared plus y squared equals r squared. Alright, so that's what we would use. Now here's the thing, that's true, but we need to bring theta into here, right? Because we know that we're using theta as a part of this thing that we have. So we need to get theta involved. So we could just use theta as an angle of the triangle. So I'm going to put theta right here, right? Now that we have theta in there, what we have to do is we have to bring sine of theta and cosine of theta into here. Well, we can figure out what sine of theta and cosine of theta are just by looking at the triangle. So the sine of theta, so if we figure out the sine of theta, what's that going to equal? Well, sine theta is opposite over hypotenuse, so opposite over hypotenuse, y over r. So that's sine of theta. The cosine of theta, if we look at that, it's adjacent over hypotenuse. So adjacent over hypotenuse, it's x over r. So we get x over r. So that's what we get. Now what we're going to do is, notice how we have sine squared of theta plus cosine squared of theta. Well, for the Pythagorean theorem, what we have here is we have x squared plus y squared. So what we should do is we should just solve for y and x here, so we can get sine of theta and cosine theta on the left side of the equation. So if we solve for y right here, we get y equals r sine of theta. And if we solve for x right here, we get x equals r times the cosine of theta. Right? Those two things right there are huge. Right? That's huge. And so what we're going to do now is we're going to substitute y for r sine of theta, and we're going to substitute x for r cosine theta. And so that would be what we get when we substitute that stuff into here. So next we can expand our parentheses with that exponent, so this will become r squared, I'm just going to do that, r squared cosine squared of theta plus, and for this parentheses we get r squared sine squared of theta equals r squared. And so this is what we have. All we have to do now is divide both sides by r squared. Because once we do that, r squared cancels out there, there, and there. And so you're left with cosine squared of theta plus sine squared of theta. So cosine squared theta plus sine squared of theta equals, we have r squared over r squared. Anything divided by itself is just 1. And so we get cosine squared of theta plus the sine squared of theta equals 1. And so that's where it comes from. All right, cosine squared of theta. So cosine squared of that angle plus the sine squared of that angle will always equal 1. And so that is what this comes from, right? That's it.